This video is about finding greatest common factor. Greatest common factors have a few other names. In this course, we'll use GCF for greatest common factor. If you factor a set of numbers, we're looking for the biggest factor, the biggest number that they have in common. So there are lots of ways to do this. I'm going to focus on prime factorization because prime factorization is going to be a useful skill throughout this course and future courses. It's not much harder than regular factorization and, in my opinion, becomes easier once you're good at it. So, for example, let's take the GCF of 8, 12, and 20. Two ways I'm going to show. One is to use the ladder, and the other one is to use those trees. So first we'll use the ladder. We'll write out 8, 12, and 20. We'll divide by whatever number, divide them all by the same number. I'm going to start with 2. 8 by 2 is 4, 12 by 2 is 6, 20 by 2 is 10. I'm going to go again. Looks like 4, 6, and 10 are all even again. So 4 by 2 is 2, 6 by 2 is 3, 10 by 2 is 5. And now, once I reach this point where I can't divide all of these by the same number, I stop. So, to find the GCF, I just take that 2 times the 2, and the greatest common factor of 8, 12, and 20 is 4. If I was going to do LCM, then I wouldn't stop there. If I was going to do LCM, I might not have given myself enough space to do it. I would go by 2 again. I definitely didn't. By 3. And you can imagine by 5, 1, 1, 1. Sorry about the squishy video there. But the LCM would be 2 times 2 times 2 times 3 times 5. Which is 2 times 2 times 2 is 8, times 3 is 24. And 24 times 5 is bigger than 100. If you do this mentally, you might want to think, okay, if it was 25 times 5, it would be 125, and I'm 1 less than that each time, so I'm down to 120. Or you can use a calculator, I don't care. It would be 120. So for GCF, we would stop as soon as we can't work with every number. As soon as it doesn't work for at least one of them, we're going to stop. For LCM, we would have kept going. I like this method because the ladder lets you find either GCF or LCM, and all you have to remember is, when do I stop? The second method is going to be the tree method. It doesn't have to be with the trees. It's just finding all of the prime factors of each of these numbers. I know the tree method is popular, so I'll do it. So again, we start with our 8, 12, and that's not 10, is it? It was 20. Let's make it 20. I wrote that out wrong, sorry. For 8, 12, and 20. For 8, we have 2 times 4. 4 breaks down into 2 times 2. As soon as we hit primes, we know we're done. For 12, we can say 2 times 6. You could have gone 4 times 3, it doesn't really matter. And for 6, we can do 2 times 3. And for 20, we can do 2 times 10. And for 10, we can do 2 times 5. And now we're looking for what factors are shared. So I'll just change colors here. We've got a 2 here, a 2 here, and a 2 here. So there's definitely a 2 there. We've got a 2 here, a 2 here, and a 2 here. So there's another 2 there. I don't know why I wrote out LCM either. GCF. Other than that, we've got this 2, this 3, and this 5. Nothing in common across all of them. So it's just 2 times 2. So the GCF is 4. Same answer as before, right? GCF of 4. LCM would be the same too. If we were to multiply out all these prime factors, we'd get 120 again. Both of them work both ways. So again, for GCF, we're trying to find all the factors and then which ones are in common across all of them. So if we're doing, oh, I didn't mean to write this out ahead of time. I'll work through it with you. I just made sure I had enough space to work before. Okay, we're down to it. So If we're looking at LCM versus GCF, it helps to take a look at an example. So 18 and 27. Why 18 and 27? I don't know. They're two numbers. I'm going to find the GCF and the LCM for both. And then I'm going to draw a little diagram to show like something they have in common and some difference. That's a Venn diagram, shows commonalities and differences. Or we would say in set theory it shows intersections or unions of sets. So for GCF, we're looking to stop as soon as it gets hard. So 18 by 27, I can divide by 3. 18 by 3 is 6. 27 by 3 is 9. I can go by 3 again. 6 by 3 is 2. 9 by 3 is 3. And now I can't divide both of these by the same thing, so I'm all done. The GCF is 3 times 3, which is 9. So the greatest common factor of 18 and 27 is 9. For LCM, I would have just kept going, right? So I would have said, okay, by 3, I get my 6 and my 9. By 3, I get my 2 and my 3. I'm going to continue with the 3's here just so I can group them. I get 2 and 1. And by 2, 1 and 1. As soon as I'm all at 1's on the bottom, that's how I know I'm done LCM. And 3 times 3 times 3 times 2. Or we could say 2 times 3 cubed. Either way, that's going to be 54. So we can say the GCF of 18 and 27 is 9, and the LCM of 18 and 27 is 54. Down here, though, I'm going to write out these factors. So the factors of 18 are, well, if you're doing 18, maybe I'll just draw it out here. We could say that's 2 times 9, and 9 is 3 times 3. So I have 2, 3, and 3. So 2, 3, and 3 to shove somewhere in here. And for 27, I could say that's 3 times 9, and 9 is 3 times 3. So that's 3 times 3 times 3. So I have 3 times 3 times 3 to shove in here somewhere. And I'm figuring out which ones they have in common and which ones they don't. So it looks like there's these 2 3's and these 2 3's that are in common. So I'm going to say that the shared factors are 3 and 3. The factor of 18 that's not shared, that's unique, is 2. And for 27, there's this one 3 out here that's not shared. So the factors of 18 are everything inside of this circle here. Well, it's not a circle. It's not even an ellipse, but whatever it is. So 2 times 3 times 3 is 18. For 27, 3 times 3 times 3, these 3 right here, are 27. I did not mean to get rid of that circle. Can I undo? I can undo. Good news. Right. So if we're looking for the GCF, that's the factors they have in common, 3 and 3. Greatest common factor is 9. And if I'm looking for LCM, that's all of those. 2 times 3 times 3 times 3. Or I could write 2 times 3 cubed. Either way, it is equal to 54. So this is just meant to show the differences and similarities between the idea of LCM and GCF. GCF is the factors they share in common if you put all the prime factors of the numbers together. And the ones that don't get shared would also be included when you're finding LCM. I hope it helps.